Today we will talk about the buses 240 plus performance. So for this PowerPoint, it will divide it into 4 parts. First one, we will talk the general specification. The part 2 about the component introduction. The third one is the consumables. The last part I will teach you how to setting the parameters. Now we go to the part 1. General specification. For general specification, we will learn the machine together. As you can see, the picture shows us the buses 240 plus. The throughput up to 240 tasks per hour. Exactly, it can work with the IC module together, but the IC module is optional. Throughput up to 200 tasks per hour. For sample position and the reaction position, they are the same. There are 45 fixed position and 45 interchangeable position. I will show later for this part. For the water consumption, up to 2 to 3 liters per hour. It's better for you to remember about this one because we will talk the buses 240. This is very different. For the reaction QV, there have A group. Each group have 10 qubits, so we can got the total reaction qubits up to 80. The reaction value is 100 to 318 microliter. And we will calculate 16 wavelengths. Because the size is very small, so it is targets for the small size laboratory. Now we will talk about the buses 240. Exactly, they're almost the same, but for the water consumptions, this one is 1.5 to 2.5 liter per hour. Because for this one, you have to wash manually. They don't have the washer. This is about our buses 240 and 240 plus. For our second part, we will learn the component together. Now, let's go to the picture. As you can see, our machine is very small, so for this picture, you have to remember each component's position. First one, our reaction disk, our sample and reagent disk. This is for the optical system. Washer, but you have to know the washer only for buses 240 plus. This is the mixer, our sample and reagent probe. Exactly, if you have installed the IC module together, you will find the IC module in this area. Okay, for this PowerPoint, you have to remember each component's position. Now we will talk about them one by one. First one, our sample and reagent disk. We have mentioned before for our sample and reagent disk, they can up to 19 sample positions and up to 19 reagent positions. For the sample, it also can continuously loading. Yeah, this is the outstream to put the sample. And it supported 2 type tubes. One is the polytype tubes, another is the standard cup. It depends on our end user itself. And it have the cooling function to increase the stability of reagent in 2 to 10 degrees. You can see there have 3 range, outer range, middle range, and the inner range. For the outer range, there are 45 fixed sample positions. For the inner end, also 45 fixed reaction position. The middle end, you can put the reaction or the sample. It depends on yourself. So for this 45 position is interchangeable. For the reagent, they have two sizes. One is 50 milliliter, another one is 10 at 30 milliliter. This is for the 50 milliliter. This one is 10 at 30 milliliter. So this is all about the sample and the reaction disk. Now this one is for the sample chip size, standard cup, or another one. It depends on yourself. Okay, now we go to the next part about the sample and the reagent group. As you can see, sample and the reagent group. That means this one can add the sample and reagent. For the sample, it can add 2 to 35 microliter with steeping 0.1 microliter. For the reagent, it can add 20 to 350 microliter with steeping 1 microliter. And it has the anti-collision and self-recovery function. We also have the liquid level detection and the clot detection. Also have the highly polished to prevent the close contamination. So this is about our sample and reagent group. Next one is about our reaction disk. We just mentioned there have 8 groups, right? We calculate together. 1, 2, 3, 4, 5, 6, 7, 8. 8 group, and each group have 10 qubits. So totally there have 18 reaction qubits and have the optical plastic material. I will show in the next picture. The reaction value is 100 to 318 microliter. You have to remember. And this is the incubation temperature. Exactly for the process 240 plus and process 240, the reaction time also be certain, 12 mm or 32 mm. Now we go to see more detail about the reaction qubits. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 qubit, one group. And we recommended that you replace the qubit in 6 months or when you necessary. This one. The optical path is 5 millimeter. The process 240 plus, the qubit is reusable qubit. For the process and 240 is disposable qubit, so it's different too. You have to divide. Next one is about the mixer. There have one thing to mention. For the mixture, it will wash with the preheating water before mixing. That means it will easy to wash, right? And the structure is very simple. They'll have the U-guide to make sure the mixer can move properly, and have the anti-collision and self-recovering function. The next one is about the washer. The washer station is only for process and 213 plus. As you can see, they have 4 needles, so they have 4-step washing procedure. And it also needs to wash with the preheating pro water and the detergents. And it can automatic QV wash and cell blank check. The next one we talk about the optical system. As you can see, there's some parameter about it. This is the position for us to put the lamp. But you have to remember one thing, the lamp life. 2000 hours. After 2000 hours, you have to change the lamp. And the next part, we will talk about the consumables. As we all know, process system, it is the open system. That means we can use others reagent or use others consumables. The other company also can use us. So now we will talk the consumables. The first one, alkali wash. It is used to wash the sample and the reagent probe and reaction qubits of automatic biochemistry analyzer. When we use this alkali wash, you have to know which position do you load it. You have to use a standard cup and load it in W1 position. And this is the first function for it. Another function, you use it as the wash liquid. So you have to dilute the alkali wash with distilled water in a ratio of 1:8. For these consumables, we have to keep at 10 to 30 degrees and protect from light. This is about the alkali wash. And the next one is about the hydrogen. Hydrogen is used to wash the sample and the reagent probe, stirring arm and reaction qubits of automatic biochemistry analyzer. But how to use it? Add the hydrogen to 15 ml reagent bottle and load in 19 reagent positions for washing the sample and the reagent probe, stirring arm and reaction qubits. And wipe or shot the reaction qubits with 2% hydrogen when necessary. It also needs to keep in 10 to 30 degrees and protects from light. The next one is about the acid wash. The acid wash is mainly to use clean cross-contamination. But how to use it? You pipe the acid wash in a standard cup and load it in W2 position. The storage requirements is the same as the hydrogen and alkali wash. This one, IC cleaner. When you install the IC module, you need to use this one. It's to wash the IC tubing. It's the same, you need to pipe the IC cleaner at least 215 microliter in a standard cup and load it in the ideal sample position. The position you can add by yourself. And install the IC cleaner at 2 to 8 degrees, protects from light. So that is all about the consumables. The next one, we will talk about how to set up the parameters. For the basic parameter, exactly we will give you more detailed introduction in the SOP PowerPoint. So for this turn, you have to remember some key points. First one, you click the basic parameter in the assay parameter. It will show you like this. For the assay number, assay full name, all of this you will find in the inserts for use. So don't worry. But I want to mention in the reaction direction, absorbance limits, pressure check, because these three is very connection with each other. When it's exceeding the absorbance limit is 3.3 and you need to click upper, the parameter is 3.3. Otherwise, if this is the setting, the absorbance will put 0 and this one will be lower. This part you will need to set negative 3.3. Yeah, this PowerPoint will show you more clear. Input 0 in the negative reaction or 3.3 positive reaction in the absorbance limits. And in the pressure check, if such check is not carried out, you need to input negative 3.3 and the direction is lower, or 3.3, the direction is upper. Mean this. upper or lower, negative or positive 3.3. This one is 3.3 or 0. So it's very connection to the reaction direction. This is one thing we have to clear. Another one is the calibrated parameter. For this parameter, you no need to change, and the measure is the same like the basic parameter. The other thing you no need to change, we will give you more introduction in the SOP PowerPoint for this interface. And this one is about the effective photometry points calculation. In our biochemistry 214 and biochemistry 214 plus, one cycle needs to use 15 seconds, and the procedure is to add the reagent 1 weigh about 18 points, and then we need to add sample, also weigh for about 18 points, then add the reagent 2 to begin the reaction. So this is the procedure. We will according difference measure to calculate the points. The first one, we will talk about one end points measure. This is the chart to show us the procedure. As we can see, they add the sample and then mix roughly incubated at 37 degrees for 10 minutes. So this is the time for us to calculate. We know one cycle is 15 seconds. So 10 minutes, it will be 10 minutes multiplied 16 seconds, then divided into 15 seconds. We will get 40. So that is why 10 minutes equal to 40 points. Because this is the one end points measure, so it only rate 40 these points. It's very easy for it to calculate. The next measure is about the two end points measure. We see the procedure, the test procedure. First, sample value, calibrator value, purified water value, and it add reagent 1. Then mix thoroughly, incubate at 37 degrees for 3 to 5 minutes, and then read the absorbance. Then add the reagent 2. Mix it at the same temperature. Read it 6 minutes later. You can see 6 minutes later. But for the process 240 and the process 240 plus, they are the same because they need to weigh about 18 points. That means after you add the sample, you need to weigh about 18 points. We will add the reagent 2. Thus, the most important is in the 16 minutes. 16 minutes multiplies 16 seconds, then divided into 15 seconds. So this is according to the time we can calculate it out. But there have the first points is 18. So the second point is 18. It's 18 to 8 these time points. At last we got 42. The first point is 18. So it's from 18 to 42. This is about the two end points measure. The next one is the red A. Only when we add the reagent to the reaction will begin, so we have to pay more attention in this part. After 1 minute, read the absorbance for 2 minutes. So now we have to calculate it. Because this is the procedure at the sample, we need to weigh about 18 points. And then add the reagent 2, incubate 1 time. incubates for 2 minutes. So they have 2 points, right? This is the procedure. So the first point is 1 plus 6 seconds to divide it into 15. But you have to add the 18 points. And the second point is 3 minutes because this 1 minute, right? This is 2 minutes. So they have to add together to multiply 16 seconds. Then also need to add 18. Thus, we can calculate the effective photometry points is from 22 to 30. This is the red A. Difference measure, the calculation is different, so we have to know how to do it. The last one is 2 points rates. Also pay attention when we add the reagent 2. You can see after 2 minutes, ray for 3 minutes. 2 minutes multiply 16 divided into 15 and then add the 18 points. The second point is the same, so we can get the last result. You can use different inserts for use to try it. So that's all about this PowerPoint. Thank you for your listening.